Hello everyone, I'm Dr. Meera Mishra. Friends, in previous lecture we discussed about the measure of dispersion. Today we will learn we will learn we will learn various techniques to distinguish between various shape of a frequency distribution. Right, friend? So in this lecture make you familiar with concept of skewness and kurtosis and its measures, right, friend? So now what exactly skewness? So first we talk about the skewness. So what exactly the skewness? Skewness, friends, skewness means a study of curves. It tells you the amount and direction of skew, right? Or if you write, then measure the degree of a symmetry. Measure the degree of asymmetry. Or describe the lack of symmetry. Describe the lack of symmetry in frequency distribution. Right? So now what exactly is skewness? Let us understand what is the skewness, right? So friend, now I draw a three frequency curve, and if you observe carefully, now you see, friends, in the first curve, and this is the axis of symmetry, and here mean equal median equal mean equal mode, right? This is x and this is y. This is x, this is y. This is x, this is y. In here, this is mode, and axis of symmetries, like suppose in this line shows the axis of symmetry, right? And this is mode, and here this is mode. This is mean, this is mean, this is mode, and here the median. In this case, here the median, and this is the mean. So friend, in first case, this is symmetric, because if the frequency are equally distributed, what is the symmetry? If the frequency are distributed frequency are equally distributed on both sides the central values, right? So you see, if you draw the symmetry, you draw axis of symmetry, you have both sides identical halves, right? So we said here the frequency distribution is symmetric. So this here the frequency distribution is symmetric. Right? Now, if you see the second one, in second case and third case. In second case and third case, in positive side, you see in positive side, this is the positive side, tailed developed. Positive side tailed is developed, you know very well, this is the positive side, this is the negative side. So in here tailed is developed. Or in third case, in negative side, the negative tailed is developed. So both are not symmetric. Both are not symmetric because if you see around you see axis of symmetry, you have both sides not identical halves, right? Not identical halves. So both are not symmetric. So these curves are the asymmetric. So frequency in second case and third case, frequency distribution is asymmetric. Asymmetric, right? So in this case mean median mode equal to, in this case, in second case, mean greater than median greater than mode, and the third one case is your mean is less than median is less than mode, right friend? So the frequency distribution, whenever the frequency distribution is symmetric, a frequency distribution is said to be skewed if the frequency are not equally distributed on the both sides of the central values, right? So a skewed may be positive or negative. You see, in this case skewed is positive because tailed is developed in positive side, and in this case skewed is negative because tailed is developed in negative side. So both case are in both case, second case and third case, this one is positive skewed and this one is negative skewed. But in this case, in the case 1, there is no symmetry because frequency distribution is symmetrical. So there is no symmetry, right friend? So it means skewness is related to or measure the degree of the asymmetry, right? So friend, asymmetry are two types. First one is positive skewness and second one is negative skewness. So you write here, so asymmetry are two types. First one is positive skewness, skewed, and second one is negative skewness, or you can say positively skewness distribution and negative skew distribution. And because here, why this one is positive? Because positive tailed come. If positive tailed come or develop, and in this case negative tailed develop or come, right? Now, how do you measure the skewness? How do you measure the skewness? So, measure of skewness tell us the direction and extent of skewness, right? Now, friend, so write down the measure of skewness. How do you measure the skewness? So, basically, measure of skewness measure the degree of asymmetry, or you can see measure of skewness tell us the direction and the extent of the skewness, how much it extend, right? Now write down the way of how to find the how to measure the skewness. So write down measure of skewness. Measure of skewness. Friends, measure of skewness three types. The measure of skewness are the measure of skewness are, first one is Karl Pearson coefficient of skewness. Karl Pearson's coefficient of skewness, right? And second one is Bowley's coefficient of skewness, and third one is Keeler's coefficient of skewness, right friend? Coefficient of skewness. Now, so taking the first one, Karl Pearson coefficient of skewness, it is very important for measuring the skewness. So take first one. So move on first one. I have taken Karl Pearson coefficient of skewness. So friend, the formula for measuring of skewness as given by Karl Pearson is as follows. The formula given by Karl Pearson is, it is denoted as SKP because this is the Karl Pearson, so we denote here SKP is equals to mean minus mode upon 2, and we know that mean minus mode relation is equal to 3 times mean minus median. If you want to if given a median value, so you use the formula of this one upon 2, sorry not 2, this is the standard deviation, right friend? So this is the standard deviation SD. So friend, the value of the coefficient of skewness is 0 when SKP equal to 0. So distribution is symmetric, and if SKP, it means skewness is 0, it means distribution is symmetrical. Is symmetrical, right friend? And if SKP greater than 0, it means distribution is positively skewed. Distribution is positively skewed, right? And if SKP is less than 0, then distribution is negatively skewed, right friend? Normally the coefficient of skewness lies between the +1, and if mean is greater than mode, the coefficient of skewness will be positively. In this case, if suppose then this condition, or suppose then mean is greater than mode, so distribution is positively skewed, and if mean is less than mode, then distribution is negatively skewed, right friend? Now come to the second measure of skewness, and which is Bowley's coefficient of skewness. Bowley's coefficient of skewness. Friends, Bowley is also the statistician and developed a measure of skewness which is based on quartile values. As you know this term quartile, because I am talking before lectures, what is the quartile. The formula for measuring the skewness given by Bowley, which is the formula given by Bowley for measuring skewness is this is defined as SKB. Here SKP, because Carl Pearson, here Bowley is involved, so SKP is showing the Bowley's coefficient, right? And this is based on the quartiles values. So this is which one values? Q3 plus Q1 minus 2 median upon Q3 minus Q1, right friend? As you know the Q3 and Q1, Q3 is where Q3 is quartile third or third quartile third, and Q1 is quartile first, right? And as you know the median. Similarly, just like a Carl Pearson, if SKB is equals to 0, symmetrical distribution, symmetrical distribution, or you can say distribution is symmetrical if SKP here you also write the if SKP is greater than 0, positively skewed distribution, and if SKP is less than 0, negatively skewed distribution. Right, friend? So this is the Boyle's coefficient of skewness. Right, friend? Now move on. Next, Cayley's coefficient of skewness. Cayley's coefficient of skewness. Third one is Cayley's coefficient of skewness. Friends, this is called Cayley's coefficient of skewness because Cayley developed another measure of skewness which is based on percentiles and deciles. So the formula for measuring skewness is as follows: SKK, because developed by Cayley, so this defined as SKK equal to, I am talking about the Cayley coefficient of skewness based on the percentile and decile. So first we write the based on percentile. So this one is a based on percentile. Right? So what's the formula? SKK equals to P90 minus 2 times P50 plus P10 upon P90 minus P10. Friends, I told before, I discussed before my videos or lectures. You see what is the decile. You see, if you want to see the lecture percentile, deciles and quartile, so you go and learn and watch this video where I show how to find the percentile, deciles and quartiles. Right? So here P90 is percentile 90. Here P90 is percentile 90. P50 is percentile 50 and P10 is percentile 10. Right? So this formula is based on the percentile. Similarly, based on deciles, because Cayley gives the formula based on percentile and deciles. So now second one is based on deciles. You see my lectures. There I told you how to compute these values. D9 to D5 plus D1 upon D9 minus D1, where D9 is deciles deciles 9, D5 deciles 5 and D1 deciles 1, right? So these are the, similarly if skk is equals to 0, here if skk 0, so distribution, symmetrical distribution, if skk is greater than 0, so positively skewed distribution, and if skk is less than 0, negatively skewed distribution. So these are the, friends, these are the measures of skewness, how to find the skewness, right? Now move on, next topic, kurtosis. Kurtosis. What is kurtosis? Friends, kurtosis tells you how tall and sharp the central peak, while skewness signifies the extent of asymmetry. As you see the above, kurtosis measures the degree of peakedness of the frequency distribution. Kurtosis measure the degree of peakedness of frequency distribution. Carl Pearson classified curves into 3 types on the basis of the shape of their peaks. So Carl Pearson's classified curves into 3 types on the basis of the shape of their peaks, right? So these are the these are the 3 types: mesokurtic, second one is leptokurtic, third one is platykurtic. So these 3 types of curves are shown in I have shown these 3 types of curve. Suppose in these types of curve. So friends, in this case, the first one is where peak is high, so this one is called the leptokurtic. This is the leptokurtic, and this middle one is known as the mesokurtic. Why? I told you, mesokurtic. And because this one is a flat one, so this curve is known as a platykurtic. So when curve is called leptokurtic, when called platykurtic, and when it is called mesokurtic. For this, first you understand how to measure kurtosis. So friend, kurtosis measured by beta 2. Kurtosis measured by beta 2, or you can say beta 2. Kurtosis is defined by the beta 2. So beta 2 equal to the value of moment mu4 upon mu2 का square, or you can say it is based on the gamma 2. Gamma 2 is equals to beta 2 minus 3. So friends, when beta 2 equal to 3, when beta 2 equal to 3, when beta 2 equal to 3, so the curve is mesokurtic, or gamma 2 equal to 0. It means two cases are arise, if beta 2 equal to 3 or gamma 2 equal to 0. So the curve is mesokurtic. And if beta 2 greater than 3, if suppose then beta 2 greater than 3, beta 2 greater than 3 or gamma 2 greater than 0, then the curve is more peaked. As you see, the curve is more peaked than the mesokurtic curve is, then the mesokurtic curve is termed as leptokurtic curve. Okay? And in case of beta 2 less than 3 or gamma 2 less than 0, then the curve is less peaked than the mesokurtic curve and is called a platykurtic curve. These are the curves. Right? So right here, so I write here properly. If beta 2 equal to 3, then the curve is mesokurtic. Beta 2 equal to 3 or gamma 2 equal to 0, then the curve is mesokurtic curve. Right? The second one is if beta 2 is greater than 3 or gamma 2 is greater than 0, the curve is more peaked You see here, the curve is more peaked than mesokurtic curve. Curve is termed as leptokurtic. And third one is, if beta 2 is less than 3 or gamma 2 is less than 0, then the curve is less peaked. You see here, this is the third one, this is the second one, and this is the first one. Less peaked than the mesokurtic curve is called as platykurtic. Platykurtic curve, or it is flatness curve. Right, friends? So this is the kurtosis. So this is the skewness and kurtosis. So friends, skewness is nothing. Just measure the degree of the asymmetry, or study the shape. But kurtosis measure the degree of peakedness of the curve. Right, friends? So thank you for joining my class.